Okay, so the next, describe the transformation of f of x equals x squared represented by g. Then graph each function. This is 2b. It says g of x equals 2x squared plus 1. Now, we want to describe the transformation. Like I said, I'm going to do this one in order. Okay, so over here, I kind of set it up. Okay, you have your equation that is in vertex form here. So that's our vertex form. I'm going to write that down. Why is it called vertex form? Well, from here you can get h and k represents what your vertex is. Okay, so given what we have here, first thing that I want to start out with is that we have k perfectly aligned with this 1. Since there's a plus k here and there's a plus 1 here, then I can just conclude that k in this case is 1. Okay, now h. Behind this x, there is no minus anything or plus anything. So in this case, the vertex is going to be at 0, 1. So automatically we know that this graph is going to have a point at 0, 1. That's going to be our a point on our graph. So here's what we know about that 1. Okay, so if we go back and look at what the 1 does, the 1 is in a place of k here, and that does a vertical transformation. And because we have k being greater than 0, in this case we have 1, so it's going to shift up 1 unit. So automatically we know that we're going to have a vertical shift or translation, however you want to describe it. Oh, that looks like an N. I put a U for some reason. A vertical translation, and this is going to go up 1 unit. Okay, so that's the first thing that's going to happen here. Then we have that 2. What I want you to notice about the 2 is that the 2 is inside the parentheses. So that 2 is going to cause something horizontal to happen. Now, here is our image here, and you do have this on your class kick assignment in color so that you can see the difference. Now, inside of our parentheses here, we have a 2. So what happens here, 2 is greater than 1. And so because 2 is greater than 1, we're going to have a horizontal shrink, meaning it's going to get closer to the y-axis. Okay, so because a is greater than 1, a is 2. So let's write that up. But oh shucks, we have to deal with a new concept. Okay, so give me just a second here. So we already know that it's going to be a horizontal shrink. Okay, now because a is greater than 1. But one more thing, okay? The graph of g is a horizontal shrink, but the factor of it is going to be horizontal shrink of a half. Okay, so give that just a second. Now you're probably saying, well, there ain't no half right there. That's a 2. Well, instead of multiplying by 2, we're going to divide by 2. And so for that reason, it'll be seen as a half instead of being a horizontal shrink by 2. Okay, so a horizontal shrink is like the opposite or the same as a vertical, not the opposite, the same as a vertical stretch. So let me put this on paper for you so that you can see it. Okay, give me just a second. Okay, so here we go. I went ahead and I set up the very first example here. It says g of x equals 0, because like I said, I always like to see what's happening at the origin. Now, I will hope that right now your brain is like, wait, Ms. Gable, we already have a point at 0, 1. And it does work out that way, but I just wanted to show you what it looks like written down, okay? So if I substitute in a 0 there for x, and I multiply anything by 0, I'm just get 0. So this is like 0 plus 1 right here. And so for that reason, g of 0 is 1. And that happens to be our location for our vertex. So at 0 and a positive up 1, we have a point there. Okay, so now we get to see what's going to happen with this horizontal shrink. Okay, so I'm going to do, let's see here. What if I do 2? Let's see, what happens if I do 2? All right. And like I said, this part right here, you're really kind of just picking numbers to see what's going to happen. Sometimes there is like a little bit of rhyme and reason with it, but sometimes it just, hey, let's just see what's going to happen. All right. So here we go. We have 2 here. And so 2 times 2 is 4. Uh-oh, that's going to be too big. All right, so 2 times 2 is 4, and we have 4 squared plus 1, and so that's going to be 16 plus 1, so that's going to put us at 17. So that is way off of our graph. So what about if we just do 1? Okay, let's look and see what happens at 1. So, and we can always change the scale of our graph. It doesn't necessarily have to be, you know, a graph that's going by 1, but I already graphed the parent function there, but shucks. Let's go. 2 times 1 is 2, so that's going to give us 2 squared plus 1, and that's going to be 4 squared. I'm sorry, 2 squared is 4, so 4 plus 1, that's going to give us 5. So then what we know here is at 1, 5, we have a point. Okay, so let's see, 1 and 1, 2, 3, 4, 5. All right. Okay, so if I have a point at 1, 5, we did not shift to the left at all, so this should be symmetric about the y-axis. So if I have a point at 1, 5, I'd also have a point at -1, +5. And so what happens is, what you probably already can see, is that this graph gets a whole lot narrower. Okay. So it moves closer to the y-axis. I don't know why I'm losing my words. Okay, but anyway, it moves closer to the y-axis. So it is a horizontal shrink, meaning we relaxed our arms horizontally, but a horizontal shrink looks like a vertical stretch. Okay, so keep that in mind. We don't do a whole lot with horizontal stretches and shrinks, but yeah. So that concludes example 2B. And I already said, oops, I want to make sure, just in case, because I may ask you about your vertex. Your vertex in this case is at 0, 1, which our vertex, and I put it in another video, but just in case if you missed that one, the vertex is whatever coordinates you have for H and K, and this is known as vertex form. Okay, so you got questions? We want to hear them. Let us know, okay? Don't you hold on to your questions and be like, oh, I'm going to do it next time. Why am I asking tutoring? Why come to tutoring if you can ask in class? Okay, so anyway, let's have a great day, folks.